All right, class, welcome back. I hope you guys saw the previous video regarding distribution or multiplying a monomial with a trinomial. So we're moving on to the next one where we're multiplying two binomials. So binomial is two polynomials. The word binomial, if we write it right here, binomial comes from the word bi, which means two. So it's a polynomial of two terms. Polynomial of two terms, right? All right. So here we're multiplying two binomials. So here's the binomial, and here's the binomial. It's important for us to know that to distinguish that these two are separated binomials, we use parentheses to tell the reader that these two terms are grouped together and these two terms are grouped together. And of course, like we said before, even though there's no dot in there, the assumption is that this is a multiplication, right? So let's begin. So how we're gonna multiply these two? So we have a specific rule. Maybe some of you guys will know it. The rule as foiling. It's sort of kind of like we are using distribution in a different level. Um, so some of you guys know as FOIL, right? The expansion of this multiplication. I don't like using the F word, that was a little joke. But so I have a specific way I think about it, right? Is the same kind of nature that we used before. It's a distribution of the term to the other group. So what I'm saying here is, if I use distribution of this term to these two terms, right? If you notice, to this group right here. So I'm gonna do the distribution, kind of like what I did in the other one, and then I'll use the then I once I'm done with that, I'll distribute this term with this two terms, right? So that's what I'm gonna do. This is my plan. So I'm gonna go ahead and rewrite it. So I'll keep the coloring. So I apologize if these colors are not the best for you. So I'll start with 3x times 2x. So 3x times 2x, followed by this plus sign right there, and then 3x times 4. So it'll be 3x times 4. So there you go. So we just took care of the distribution of 3x. Now let's jump in and do the distribution of negative 3, right, this one. And we're going to do with, so now this minus right here is going to be this minus right here. So this is going to be this one right here, right there, 3x times 2x, so the 3x times 2x, and then we have this plus with this minus, right? So negative times a plus will give us, remember the rules of, if you have a negative times a plus, this gives you a negative. If you have a positive times a negative, this gives you a negative. If you have a positive times a positive, gives you a positive. And then two negatives makes a positive, right? And that's not true in life, right? But in math it is. So negative 3 times positive gives you a negative. So we're going to have a negative here, negative 3 times 4. All right, so do you guys see how we were able to have the distribution? And we're going to follow the same technique that we did before. We're going to multiply 3 and 2. That will give us 6, and then multiply x, and like we did before, right? X times x, we think about them as having imaginary ones in there. And so when we multiply the variable, we add the power. So we have x to the second, right? Now, of course, as we go through, you probably are doing that in your head, and that's common and that's best practice, right? So 3 times 4 is 12, and we only have an x, so this, think about this as being like a x to the 0, right? We talked about that last time, right? So imagine there's an x to the 0 there, and because x to the 0 is equal to 1. And so we have x to the 1 plus 0, which gives you x. So anytime you have you only have one variable, so you just carry the variable. That's pretty much what we usually try to do. So 3 times 2 is 6, and then x times x. Did I do something wrong? Yes, I did. And I apologize. There was no 3 here, right there, right? There was no 3 there. So it was just like this. It was this 3. Let me correct myself. This negative 3 was multiplied to this 2x. So I apologize for this. You probably got stuck in a few seconds there when I made a mistake. You were like, why did he put the x there? So sorry about that. So negative 3 times 2 is negative 6, followed by the x. We carry that x, and then minus 3 times 4 is 12. And there you go. So we have the product, but this is the product, but this is not a simplified answer. We can see here that these two can be combined, right? Why can these two be combined, and why not these two, right? Well, we want to think about them as, what we call like terms. So let's write a note here. Like terms. Like terms is whenever you are adding the same item. You're adding or I don't want to put that, or subtracting the same item, right? And what I mean by item, I'm saying like terms, the same variable. The same item could be as an expression, right? But and in this case, I'm just gonna say, think about that. If you're adding 12 apples with 6 oranges, right? 12 apples, let's say minus 6 oranges. When you're doing this and you're gonna say, oh, well, then what's my result? Is it gonna be 6 something? Like, what is that gonna be, right? What's the item gonna equal to? So it doesn't really make sense to add apples and oranges, right? There's even the saying, right? They're apples and oranges, they're different. So you cannot do that. But if they are the same item, right? If they are the same items, then it does make sense. You have 12 apples minus 6 apples, you get 6 apples, right? So that makes sense. That you can subtract those two. So that's what happens in here. If you think about it, these two are 12 apples minus 6 apples. 12x minus 6x is going to be 6x. So the reason, and then let's take 1 second here, that these two wouldn't be able to combine. Why? Because this is a different item than this. We know that x squared is different than x, right? They are different, right? For example, let me tell you, if x is a variable, right? A variable is something that varies. It could be any number. We don't know, so we don't have to get a whole or we have to attach this to a specific number. But if we just think about that, it's any number. So let's pretend that we had 3x versus 3 squared versus 3. We know that this is 9, and we know that this is 3. So these two are different. So we know that x squared and x are different items. So therefore, these two cannot be combined. Just like these two cannot be combined, because this has this is adding 6 apples. This is just a constant, right? It's not gonna be able to combine with this 6x. So what do we do with these two? We don't have to stress about it, right? We just have to carry them up. And we just carry them up to the next line, right? We cannot do anything about it. So that's it, right? So this is the conclusion, right? We multiply these two binomials, and now we have this, right? So we got a result. So we multiply, we expanded, right? When we multiply, we expand, right? And then the end result here was a trinomial, right? And it's important for us to think about, because it will make sense in the next when we talk about factoring later on. All right, so that's it for this video. We'll see you next time with the next